so unit 4 is all about quadratics. So I'm going to remind you what that is today. I'm going to talk about the two different formats for quadratics, which is vertex and standard, and then we're going to talk about solving quadratic equations that are in standard form. So that's our three objectives there. Why do we, so the main thing, I'd say the main mathematical thing, because the first two are really just definitions. The third thing there that we're doing is the main math part that we'll be working on today, and it's solving quadratic equations. Why do we want to do that? It helps you find the x-intercepts. It also is going to be something that we use to solve systems of quadratic equations a little bit later on as well. So go ahead and proceed. Did you get it on the little printer thingy, the handout, the notes? Yeah. Okay, good. I saw you writing. Oh, okay. Okay. So what is a quadratic equation? It's a polynomial function where the highest power is 2. So both of these have an x squared. The first one here in standard form has an x squared. The one over here in vertex form has an x squared. And that's what a quadratic is. Quadratics are probably one of the most useful kinds of equations, particularly in things like physics and stuff like that. Very, very useful. They're used to model free-falling motion under the influence of gravity. They're just pretty useful things in general, so you see them over and over again in math classes. The way you solve it is with the good old quadratic formula. You guys remember that? So, now the key here though is that this is only going to work. So basically, if you ever want to find what value of x would you plug in order to get it to equal 0, that's when you use the quadratic formula. So two things. It helps you find the x value. Second thing is when the y value is 0. So that's what the quadratic formula does. It helps you find the x value when the y value is 0. That's its function. Okay. You guys remember this from Algebra 2? The square root of a -1 is an imaginary number. And if you square the I, it becomes a real number, -1. We'll probably see a little bit of that today as well. All right, so there we have it. Let's go ahead and write down example 1 there. And we'll get started. Okay, so it says solve for n, right, when f of n equals 0. Okay, so in other words, we want to find out what the n value is when that whole equation equals 0. Okay, so that's a perfect setup for the quadratic formula. I want to find the input variable when the output is 0. That's what the quadratic's for. So we're going to go ahead and label these. This is my A value, this is my B value, and this is my C value. Okay. So the first thing I like to do when doing the quadratic formula, I think the biggest issue with students is either A, remembering the formula, or B, doing the order of operations correctly. So the first thing I like to do, and I think this can prevent a lot of errors with signs and stuff like that, is if you just start off with parentheses where all the letters were, it could really help. You're basically setting up a template where you just have to plug numbers in. Okay, so that would be my encouragement to you on how to start there. It's just to start off with blanks where the A, B's, and C's would typically go in that formula. So I just basically copied down the formula that I have on your guys' handout there. Just I took out all the letters and I put blanks there. So what letter comes first in our formula? It's the B, right? So what number would go in here? The -4. You do want to include the sign of the number as well. Okay. This is a B as well, so we're also going to put -4 there as well. And the quadratic formula, this one is an A value, so that would be -6. Where else is there an A value? The bottom, right? So we'll put a -6 there as well. And what's the last letter? C. So what number goes there? -2. So I suggest starting off with blanks and then filling in the blanks. That kind of helps with these negatives, right? You have these double negative situations and stuff. By using those parentheses, it kind of puts everything in its right place, so you kind of keep your mind straight with all the stuff going on there. The next thing I like to do is I like to simplify 4 groups. Okay. I simplify that one, that one, that one, and that one. So that first group, what does that first group become? Just 4, right? Because double negatives become a positive. How about that next group? 16. Don't forget to bring down this little minus here in the middle. Now let's do the next group. It's going to come out positive in the end. So we have 4 times -6, which is -24, right? Times a -2, which takes it back to a positive 48. Why is there a minus there if it's positive 48? Because it came from up here, right? All right. 2 and -6 makes -12. So that's what I like to do first, is after I plug everything in, I like to simplify those groups. The next thing I do in my order of operations is I take care of this, -32. Okay. All right. Okay. The next thing I like to take care of is this square root. So you might want to do this somewhere on the side of your paper, because that's going to take a little bit of space. So we have the square root of -32, right? Now, first of all, what's that negative inside going to be? That's going to make an I, right? You guys remember that from Algebra 2. When you have a negative inside, that means it's an imaginary number, so we're going to take that negative out of there. We're going to put an I in the front anyway. You're not going to always do that. You're only going to do that when there's a, what? Negative inside, okay? All right, the next thing we're going to do is we're going to break down our 32. Now, I don't know how you guys, do this. I just kind of break it all the way down myself to its prime numbers, but if you have a faster way, and there are faster ways, feel free to use it. But basically, by splitting that thing up, we end up with 5 2's being multiplied together. I'll pause for a second while you guys are writing that. Huh? Why are we writing what down? Oh, because we're about ready to take the square root. And what a square root does is it looks for two things that multiply together to make the same thing, right? So here's the story. You guys know turtles have babies, and then they don't like raise their babies. They just bury them in the dirt and walk away, right? So here's the story I tell. When a mommy turtle and a daddy turtle, see, they're the same breed. That's the only way they can actually make a baby is if they're the same. When a mommy turtle and a daddy turtle love each other very much, they have a baby turtle, and then they leave. You guys see any other mommy turtles and daddy turtles in there?
Yeah.
There we go. They get to have a baby too, and then they leave. And so we have 2 times 2 times I on the outside. So the outside is going to be 4I, and on the inside we have a 2 left. It's a lot of fun stuff there. So I don't know how much you guys remember, how sharp you are with your roots, but basically if there's a negative inside, put an I out there. Then for the rest of it, you break it down and take out the pairs of your turtle story, right? Or my turtle story, whatever you want. But if you have another way to take square roots, I'm totally cool with that. You guys ready to move on? We're getting there. By the way, the example I'm doing, it's like a worst case scenario. I put everything you could possibly run into in this problem. So imaginary numbers. You got to break down the square root, etc., etc. Lots of stuff. So they won't always be this crazy. All right. So we did that part that I circled, and what did I get? 4i. Yep. 4i root 2, right? So on your notes, you might want to draw an arrow from our work that we did to this, because that's where that 4i root 2 came from, right? Okay. Now what are we going to do? Okay, the last thing we have to do, if you're going to look at the 3 numbers that are not roots, okay, and it has to be all 3. It can't just be 2 of them. It's got to be all 3. There are 3 numbers up here that are not roots. 1, 2, 3. And you're going to reduce those. What's the biggest thing that could divide into all 3 of those? 4 is, right? So that's what we're going to do. We're going to divide all 3 of those by 4. Okay? Did I say that's the last thing we're going to do? Okay, I lied. But here we go. X equals, so it's, if I divide, let's make a note on our notes here so we know what that is. Reduce all 3 non-roots. And if you don't have a number here, for instance, in front of the I, then you can't do this step. You would skip it. It has to be all 3 non-roots. All right. So 4 divided by 4 would be 1. Plus and minus 1i root 2 over negative 3. So we reduced all 3 of those. Say that again. Can't you leave what by itself? Oh yeah, so you don't need to write the 1. You can choose not to write the 1. Here's the last thing. You will never see that somebody leave a negative on the bottom of a fraction. It's just kind of awkward looking. So here's 2 ways it could be written. It could be written like this, with the negative in front of the entire fraction. That's okay. Or, as hypocritical as it may seem, it's okay to have that negative on the top. Just not the bottom. I don't know. Doesn't seem to matter to me. But those are 3 ways to do it. But let me erase this, because they won't leave their answer like this. They'll have it as one of these 2 here. So there's a lot going on there. Hopefully you guys took some good notes along the way, and you can follow that example as you work through one. But a lot of stuff to do there. A lot of stuff.
Why did you get rid of the 1?
Because you don't need it. Kind of like technically, I can have a 1 here too, Madison, if I wanted to. We just don't. Yeah. So, okay. Can I clear it? Which one? This one? Reduce all 3 non-roots. So those 3 things that I circled there, you want to reduce all 3 non-roots. Huh? Yeah, whatever goes into all 3 of them. So in this case, it was 4. Yeah. Any other preguntas? All right. So lots of stuff going on here. What's this nonsense? Let's have you guys start off with number 3 here. Let's start off with number 3. Go ahead. So we plugged in the numbers and we simplified our 4 groups. The next thing that we're going to do is we're going to subtract those 2 numbers. So what is 4 minus 64, you guys? Negative 60. So let's write that. Now here I'm going to pause again. These 2. Huh? Because it says 4 minus 64. Now, we're going to now simplify this, and you guys are going to probably need a minute for that. So I'm going to pause and let you guys go ahead and simplify that square root of a negative 60. Okay? Okay. So, first of all, I will ask, well, we want to simplify this, right? The square root of negative 60. That's what we're working on right now, is this piece. We want to simplify that. So, Braden, what's the first thing we need to do on there? That's right. So we don't like negatives inside of square roots. We get rid of that, right? And then we put an I in the front instead. Okay? What's the next thing we're going to do, Gabrielle? Huh? We're simplifying this. We're going to break down the 60. So what times what makes 60? What? 6 and 10? Okay. Now both of these are not prime, so we want to keep going. What makes 6? And what makes 10? Okay. So you just keep breaking it down. And at this point, we have all these prime numbers. You can't go any further. So this is what I have now. I've got an I on the outside, and I've broken down 60 into a 2, a 3, a 2, and a 5. Okay. So my next question is going to go to Nick Smith. What can we do now?
So you take the 2 twos, and then you add them to the outside.
There you go. When a mommy turtle and a daddy turtle love each other very much, they have a baby turtle, and then they leave. And so we have the last step here. Haley, what's my final result going to be for simplifying that?
4i.
Huh? 15, yeah. So I'm going to say 2, though, right? Because when the turtles have a baby, they only have 1. So it's a 2. All right. So there's that. And now we have the following. 2 plus or minus the square root of 60 became this. All right, we have one more step. One more step to go. And Gio, what is that last step? Reduce all the non-roots by 2. So this one, and this one. So if I reduce all 3 of those by 2, let's see what we get. We would end up with, well, go ahead, Gio, tell me. Good. And we don't really need this one here. Now, I'm going to answer your question now, Xana. You said that 4 became a negative at the end. The reason for that is because on my last problem I had a negative down here. And what I told you guys is they don't leave the negative down there, so what they do is they move it back up to the top.
So like in the first step,
Uh-huh.
um,
Okay. I don't think I want to spend too long on, I don't know. We might need to practice some more. It's hard to say. But let's do this. All right. So number one, we have this. So it says negative 4x squared plus 7x plus 1, right? And this time, what does it tell me f of x equals? Negative 1. Okay. So ready? Let's write this. When it doesn't equal 0, you can't use the quadratic formula if it doesn't equal 0. It's got to equal 0. So it's a pretty easy fix. What do you think we're going to do? Yep. Just move everything to one side. So in this case, we would add the 1 over, right? 1 and 1 makes 2. There you go. And now we can use the quadratic formula. Now, I don't think I need to berate you guys by making you watch me do it again, but I do think you guys need to practice using the quadratic formula a little bit more. So here's what I'm going to do is I'm going to stop there, and then I'm going to ask you guys now to do number 2. But when you do number 2, I actually want you to take it all the way home and solve it. I did not use the quadratic formula. I stopped here because I just wanted to demonstrate that one fact. But the point is after you get it to equal 0, then you're going to use quadratic formula. So I want you guys to do this whole thing from beginning to end and take it home. Okay, so you're doing number 2 right now. All right. Go ahead and write down example 2, please. You guys will notice that I've titled this Putting It in Standard Form. Basically, it's the same issue we came across before. We want to move everything to one side. So I think you guys could probably handle this. So I'm just gonna ask you guys to walk me through it. So Xana, we need this thing to equal 0. So if I wanted to do that, what would I do? Good. So tell me what to do. Mm-hmm. What about 4n squared? Did you say, how do you put them together? Minus, right? So the point is we're going to take it off of this side, right? Good. So that's going to give me 7n squared plus 2n. I'm going to stop there, Xana, and we'll let someone else take the next one. Ashley, what would be the next thing that we would want to do? Move the 6 over. Now that 6 doesn't actually combine with anything over here. It's not a like term. So all we do is we put it next to it like that. Okay? So if it's not in standard form, all you have to do is move it over, right? And now we're ready for the quadratic formula. Okay? So I'll let you guys practice putting one in standard form. This time, I'm not going to ask you to go through and solve the whole thing. I'm just going to ask you to put it in standard form, just so we can move on. That out there. So I'm going to ask Quinn. What did you get, Quinn? Equals 0, right? So first of all, if you add the 11 over, that's where the 126 comes from. And then we're going to add the 5a over. Now that 5a does not combine with anything over here. It's not a like term with either one of those. So you're just going to squish it in the middle there where the single variable term usually goes. And that's your final answer. Okay? And after that, even though I'm not doing it, on your homework tonight you will, after you put it in standard form, you will solve the quadratic. You will solve for x using the quadratic formula. Okay? I want to throw one more thing at you. It's a little bit quicker, a little bit nicer. We don't have a lot of time. Probably just have time for a quick example. Could you guys write down this example 3, please? So guys, notice that this is still a quadratic, right? Because it has a square. But notice there's no x term. We have an x squared term, but no x term. When that happens, that's actually a good thing. It makes life a lot easier. Because all you have to do is use basic algebra to get the x by itself. You don't need to use the quadratic formula. You could, if you wanted to use the quadratic formula, what would your b be equal to? 0. It would still work. But that's a lot of extra work, as we've seen from today. When there's no b term, here's what you can do. Just solve for n. So let's do the algebra here. What would you guys do? No, actually. We want to get n by itself. What would you do? Add the 6, right? Then that would give us negative 64. Then what would we do? Divide by 6. Right? Now we can reduce that a little bit. What goes into 64 and 6? 2 does, right? Now what? You're going to take the square root. That's it. So, oops. Now we still do want to get that negative out of there, right? We don't like negatives inside of square roots. But that's the point there, is you can basically just get the n by itself. That's a nice little luxury we have when there's no b. Just get the n by itself. Now, you don't have to do it that way. You can still use the quadratic formula, but it saves you a little bit of time. Okay. So, there's actually a little further we could go here, but I'm not too worried about that right now. Because technically this has a square root on the bottom, right? You know how you're not supposed to have a square root on the bottom? Have we dealt with that in here at all? No? Do you guys know how to get square roots at the bottom? It's okay, don't sweat it. Anyway, we will see you guys mañana for your free response question on absolute values and systems of equations. Okay?